Okay, so let's start. So we are looking at this particular problem in which we have to find out the minimum operations to make a uni-value grid, right? So we will be given some grid and we have to make all the values of the grid as one value, right? We want to make all the values equal to one value. And the way you want to do it is through this x variable. So you can basically add or subtract x from each of the values and you want to make the all the values equal to one value. Okay. So that is what a question is all about. For example, here 2, 4, 6, 8, right? X is 2. So you will try to make all the values equal to one value by adding or subtracting 2, right? So let's start with its solution, right? Probably what we will be doing is firstly translating it to mathematical problem, right? So we will have, let's say uh we have A1, right? A2, A3, and A4. Okay. Now, what we will do in this particular problem, what is being asked is that A1, right, plus or minus, you can plus or you can subtract it, you can add it, right, whatever you want to do, plus, let's say it is K1, right, K1 times, you want to do it with X, okay, so A1 plus minus, K1 times, you want to do the X, right, multiply with that. Now, this should be equal to, okay, this should be equal to A2, right, plus or minus this constant will be different for A2, right? And this x, right? Similarly, this is equal to so on and for an, right? We have an plus or minus an, right, into x. So we want to make this condition true, right? If this condition is true, then we can say that this can be converted, right? This grid can be converted to a single value grid. Okay. So hopefully that is clear, right? So we were given some A1, A2, AN value, right? And essentially we want to do A1 plus minus K1x, A2 plus minus K3x, and so on. And we want to make this as a equal, right? So now, what we will be doing is that firstly, this problem did lead us to determining whether it is actually possible or not, right? To make all the values equal. And then, probably then we will be looking into if it is possible, then what will be our next step, right? So we are going to firstly tackle this part of a problem, see whether it is possible or not possible, right? So to be possible, this condition should hold true, isn't it? If this condition is holding true, then we can say it is possible. Now, if we just analyze this equation, right? A1. So let's take these two pairs only, right? A1 and A2. Okay. So A1 should be equal to plus or minus K1, right? Times X is equal to A2 plus or minus K2x, right? So if this is equal, what we can do, we can maybe take A1 this side, right? So what we will do, A1 minus A2 should be equal to, and when we are going to take this K1, right? This will be merging with this K2 and this will form a one whole constant, right? Let's say it K, right? Capital K times some X, right? So what does it mean? That the subtraction of any of two pairs, right, should be equal to some integer multiple of K, which is then becomes A1, right? Which then means that K, right? If you divide K by this, if you divide X by A1 minus A2, right? Then it should be some constant, right? And because we have doing it for A1 and A2, so it should hold for all the possible combination of A1 and AN, right? So if it so what does that mean? That means A1 minus A2, right? Modulus of, right, X should be equal to 0. Okay. So this condition should hold true. If this condition is holding for every pair, right? For every pair, then we can say ki ha, right? For every pair, if this is holding true, then we will say ki uh, our grid can be actually converted into any of the value, right? Because any of the value can be written in this form, and ultimately A1 can be transformed to A2, right? So, okay, or A1 can be transformed to any of the AN. Okay. So then what is a brute force way of finding this? So what you will do, you will basically, you have to do for every pair. So you will be going for O of n square, right? You will traverse every pair, and then for every pair you can check it. But that will be like costly, and there is a trick for this equation also, right? When this kind of equation arises, so there is another trick to handle that, right? What we see is that this guy is a multiple of x, right? So if you do mod of this, right? If you take mod, right, on both the sides, so this guy, second guy, will become zero. Why? Because if you, it is a, this guy is the ultimate multiple of x. And if you are doing mod with x, then this will be zero. Okay. So because this will be zero, then this condition will, whole condition will be like very much simplified, right? It will be A1. Let's write that down also, right? A1 plus or minus, right? K1x, right? Is equal to, and this whole condition is there, right? And if we do mod with x, right, what will we get? This guy will become zero, right? And we actually become, this actually become A1 modulus x, right? And similarly, all the values, right? All the values, this guy will going to cancel out. Okay. So it will be become A2 modulus x, right? Okay. And so on, right? AN modulus x. If this is true, then we say, ki, okay, the condition is true. And first part of solution is required there. So what we did, just to summarize up, we are given key, okay, we are given some value A1, A2, AN, and we want to make them equal, okay, by adding or subtracting x. Now you can do it by any multiple of time of x, right? So we write that equation in a form of mathematical terms. We find that, okay, A1 plus minus A1 times x is equal to A2 plus minus A2 times x, and so on, so on, so on, right? AN plus minus KN x, right? So this is a mathematical way of asking this question. Okay. Then what we can see, we took two equations, and we try to compute it, and we see, okay, the difference should be multiple of that. And one way is that you go for every pair and you check this condition. If it is true, then we can say we can make it. But this condition can actually be solved in a much better way if you take modulus on every side of equation. So this condition, this value will become zero because it is a multiple of x. So multiple of x, and when you do a mod of that, it will be zero, right? For example, 4 modulus 2, right? It will be zero. So, and 4 can be written as 2 into 2, right? So 2 into 2, modulus of 2 is zero. So these guys will become zero, right? When you are taking mod. And that is why A1 modulus x is equal to A2 modulus x is equal to A1 AN modulus x. So you just want to find this condition. Okay. And if you are able to find it, then we are done with this first part of a problem. See now, uh, this is the first part of a problem that we want whether it is possible or not. If we find any such AN which is not equal to this condition, right? So we will say, ki, okay, we are done. This is not possible. Okay. Okay. Now let's go to the second part of the problem in which we actually want to find out the minimum number of operations, right? So to find out minimum number of operations, let's see this example again, right? So we have actually A1, A2, AN, right? We have this particular value and we want to make it equal somehow. The values will become equal. So what I am actually saying, we when we are going to A1 plus minus K1x, right? And when we do that, there will be some value that will be coming, right? And the minimum operations we need to do, that is something that we want to do, right? So just to rephrase, okay. Again, we have A1, A2 till AN, okay. And suppose these are the pillars, right? Just best way to analyze this kind of question is to analyze it as a pillar, right? These are pillars. Okay. Now what you want to do, you want to find such a pillar in which you want to add some of the values in this pillar, right? And we want to cut off some of the values from some of the pillars and to make this particular height. Okay. So this is the desired height in between. Okay. And these are the height of the pillars. A1, A2, AN represent heights. And this is an arbitrary pillar, right? Which is our desired height, right? And we are going to, which all the elements going to become, right? So A1 will going to, let's say this is a AK, right? And AK is a pillar. So A1 will finally going to transform into AK, A2 will transform into AK, and AN will be transforming into AK. If AN is greater, right, we will going to cut off this value. If these are less, we are going to add some of the value. But AK will be the final value, right? That will going to become. Now we want to find out the AK. Okay. Why? Because this is a minimum number of operation we want to find out. So if we are able to find out AK, right, then what we can do, we can simply able to find out the number of operations. How? Let's also write that in a mathematical form only, right? So essentially what we want to find out is this. Just be with me, right? This is a summation and we want to find out the absolute value, right? So this is a mod, right? Because this can be any number of times. And we want to find out, let's say this is AI, right? And this is the AK. We want to find out AK. Okay. Once we are able to find out and we are able to get the differences sum, and if we divide it by X, okay, if we divide it by X, then this is our answer. So we want to find out the minimum value, and these are for I equal to I to 1 to n. Let's go through this again, right? Maybe it is not that much clear. So let's try to go through this. But this is a particular equation we are trying to arrive through this problem, right? This problem is essentially asking this. So suppose this much should be clear. Ki I want to find out a AK and I want to convert A1, A2, A3, AN to AK. Okay. So that is what it represent. Okay. Now suppose I am converting A1 to AK. So how will I do? I will be taking the difference, and because of this property, and because I know the A1 can be transformed to A1 can be written as A1 plus minus K of times X, right? I can add K1 times X, right? So basically this summation, if you expand it, right? If you expand this up, so it will exactly become like A1 plus or minus K times, right? X, and it is equal to this AK, right? We are just finding out that AK. Okay. Similarly for A2 plus or minus K2 is equal to AK. So we are finding AK, right? And once we are able to find that out, now that is not a minimum operation because one operation will mean you will take X steps, right? So whatever is the difference, because we know the difference will always going to be modulus. When you do are going to go for a modulus, it will always going to be divisible by that. So for one step, you take X step, right? For two, you take two X, right? And so on, right? So okay, uh, yeah. And finally, we want to make a AK, and this is what we got. Maybe it is not that much clear. Maybe let's restart, right? What I am saying. This is AK, this is A1, A2, AN. We are trying to make A1, A2, AN into AK. Now, how do you make, what is the cost if you want to make A1 into AK, right? If you want to transform A1 into AK. So if you want to transform A1 into AK, and we know AK will be nothing, it will be divisible by X, right? We will be choosing that AK depending on that, right? Depending on that only. So we want to make A1 into AK. So what will be the cost we are trying to find out? The cost will be AK, right? Minus A1 by X, right? Hope this is a like a mathematical equation, but how it is happening, you should be able to do it intuitively also, right? We find the difference. Now that difference is a multiple of X, right? So how many operation we do in finding out AK is when we divide it by X, right? That is how many operations we are able to reach. And if we sum that for all the values, right? We sum that for all the values by taking modulus operation, we are able to, and the minimum number of operation is what we want to return, right? So hoping this is a final question that is asking, right? So now we want to minimize this value. If we are able to minimize this value, then we got the answer. Okay. Now you know that when you are minimizing this, then you can take out this x because it is a constant, right? So this equation will again become minimum of, right, summation I is equal to 1 to n, right? And your a1 minus ai minus ak, right? And you want to find out ak in such a way. Okay. Now, uh, this is where our median comes into picture. Okay. This is particularly a property of median, right? If you have a sequence, right? If you have a sequence like this, A1, A2, A3, and these are in sorted order. Okay. So if these are in sorted order, then if AK is a median, right? AK is a median, then this value will be minimized. So basically, this is a inherent property of median. If we have a median, if AK is a median, right? So this whole condition will be minimized. Now, how it happens? Maybe it has a mathematical proof also, but it has an intuitive proof also, right? So if we are able to find out that, then we can say that AK is a median, and finding median is like pretty much easy, right? So like how median is like going to work for finding out the minimum of this equation, right? Let's now tackle this, right? If we are able to tackle this, then we are like done with the solution, because what we will do, we will find a median, and we will, once we have a median with this, then we just have to find the summation. And because median will inherently give the minimum value, so we will just find the value of this equation, ai minus ak, and divided by x, because it was the original equation, but we transform it for finding out what is the minimum value of AK, right? Because X will not have any effect. Now, moving forward, right? Moving forward, why median will be minimizing this particular equation? That is my claim. If AK is a median, then this equation value will be minimum. Okay. So let's again, uh, if you look at it, let's say A1, and I just going to take this A1, A2, A3 in an increasing order, right? That means these are in a sorted order. Okay. A3 and so on, and we have AN. Now let's say these are in a sorted order, and we does not touch anything with that, right? And we are, so if this is a, and if this is in sorted order, this is a minimum value, right? And right, this is a maximum value. Okay. So if this is a minimum value, this is a maximum value. So it should be intuitively clear. These represent nothing but the towers, right? Let's say this tower, right? And these are in increasing order because we have sorted it just have faith in me, right? So this is our tower, right? And they are increasing, right? Now, what we want to do, we want to find some tower, right? Some tower in which I can make this all tower equal to this AK, right? This AK, right? So I want to convert all tower into AK, and once I convert that up, uh, it will be minimum, right? It should be minimum. And uh, my claim is this is a median, right? AK is a median. So now it should be very much clear ki if we are going beyond this, right? If we create a tower which are less than this, right? So it is not always going to be optimal, right? Why it is not going to be optimal? Because you will be adding extra cost from this guy as well, right? A1, A2. So the minimum that you can have with your answer, right, with your actual AK tower height should reside between A1 and AN, right? It should be very much clear because if we are going beyond AN, right, beyond minimum, right? So ultimately you are creating your cost, right? And you are increasing your cost much more, right? The minimum value should be AN, right? Because if you create a tower, let's say this, so this height will be added, but and all the guys will be adding this guy because you will be cutting all the guys from here. Okay. Similarly, when we go beyond this, right? Let's say we try to create a tower here, right? And this is an actual tower. So if we create a tower, then all the guys beyond this will also be added, right? And that is not an optimal case, right? And even if you are standing at minimum, right? And even at a maximum, so and create a tower from that. So here, creating a tower at A1 means you will be cutting off from here, right? Everything. And if you are cutting it from everything, right, the cost will be definitely more. And when you are cutting it from here, right, when you are increasing the height to here, the cost will be more, right? Because you will be increasing every height, right? So it intuitively it sounds the we want to find some of the value of tower will be something in the middle, right? And that will be our actual optimal solution. But it cannot be in the right and even in a mid or max value, right? It will be somewhere in the middle, right? And if you look at intuitively, like what I'm trying to say, it's the graph of this cost, right? It will be like this. Okay. If this is our median minimum and this is our maximum, right? There will be some AK, right? Which will be going to give our minimum cost, right? So this is like how the graph will look like, okay, for this guy. Okay. If this is intuitively clear, right? Now, okay. Now, what we can do, let's say if we create a tower like this, and if we create a tower here, okay, if we are creating a tower here, then we are actually increasing the cost, but here the cost will be decreased for these guys. Okay. So what I am saying, let's say if I created a tower here, so that means I will be cutting off from here, right? All the cost. But cost will be, and from here, the cost will be increased. But let's say I created a tower here. So this might have been added a cost, but for these guys, right, you have to cut less. You have to cut less. You have to cut less. Similarly, for this guy, right, for this guy, when you are creating a tower from this height, you probably have to cut you probably have to add more these values, right? You have to add this more value. But for this guy, you will be requiring less height to be cut, right? Similarly, when you have an optimal height, right, when you are at optimal height, then you will be requiring less to cut in both the direction. So you can see if I go in one direction, right, if I go in one direction, cost will increase. If I go in also in other direction, cost will decrease, and eventually it will meet in some of the point, right? It will meet in some of the point that will be minimum, right? Now, if we have not, if we are not discussing median, right? What would be the easy way? Easy way would be, you know what? I will be able to find out what will be the cost here and what will be the cost here. And if you find out the minimum of these, then you will be able to find out, right? Matlab, if someone does not know about the median, then that is how they proceed. Let's forget about median, and I will try to make each of the tower equal to this A1, right? If I am making it equal, what will be the cost here, right? I will make the ideal AK to be this, and what will be the cost here, cost here, cost here, cost here, right? And that is how you can also proceed with this question, right? And you can use prefix sum for that. But I think if you know median and median inherently, right, do this, is minimize this kind of equation, right? If you know this, then you will be able to do it, right? And this is the intuitive way. If we have a value like this, so the difference, right? And also you can look it like this, like if you have a line like this, right? Essentially A1, A2, AN, these are in all increasing order, right? If I choose this particular point, middle point, right? So the distance, right, between this and this will be less, right? On the contrary, if I choose this point, right, distance probably will be less from this side, but this will be very huge from this side, right? So it is always best to choose somewhere in the middle so that we can be able to find the minimum cost, right? Because if you go here, the distances from here will be stack up. If you go in this direction, distances from here will stack up. But if you are choosing at middle, right? If you are choosing at middle and find the optimal point, then you will be able to actually play safe and the distances will be eventually lower. Okay. So it's like you move one step and you get closer to one of the houses and much closer to right of the houses, right? But you get one step far away from left of the houses, and you reach to the point in which you are far from the left of the houses, far from the right of the houses. But this cost is minimal, right? I Probably you can also look at its mathematical proof, but this is how this function look like, right? This is a cost function, right? This particular function. See, it will be converging always at AK. Okay. It will be always converging to AK and AK is a median. Okay. Just to summarize key what we are going on, right? We saw this problem, right? With this problem, right? A1, A plus minus X, we find out key what will be the condition for validity. Once we know the validity, we are claiming key this particular equation is what the question is demanding to minimize, right? We find ai minus ak, and when we divide it by x and we do summation, it should be minimal, right? That is what a problem is demanding. Then we see ki, okay, we can remove this x, and this problem looks familiar, and this is the inherent property of median. If this kind of equation is there, right, you want to minimize the absolute distances. Absolute distances can also be said as a distances, right? So if you have a distances, so basically if you want to distances and you want to find out where the distances will be lowered for every of the houses, then AK stands out to be a median of the array. If you find out the median of the array, you will be able to actually reduce the distances of all the houses in a row, right? Yeah, okay. And you want to find the summation of that. So yeah, probably after this video, you can also check this proof, like how this happens. But after this video, like you should be clear ki we- this much should be clear ki we cannot go beyond. And even at the cost of this, right? My all the even when I am at the edge, right, in a minimum or the maximum, the cost will be higher. And as soon as I am moving here, my cost will be slowly progressing down, down, down till I reach one point, and then again from my cost will be increased because of my left subparts, right? So that should be clear, and that is why the median is something is like used. But if you don't convince with that, you can go with prefix sum, right? Prefix sum is also easy. Like you want to find a prefix sum in which you find a differences, right? And keep on accumulating that differences, and you then multiply with k, right? There is a very good video for Leetcode, right? He has implemented it with prefix sum. If someone does not able to get it, you can refer that video. But that is an idea, right? You want to find out AK, and you want to add some of the towers, you want to cut some of the heights, and you want to make it. But generally, I request you to just take this because this is like important property and majorly used in variety of questions, right? When you want to, you have a distance, and let's say you have a distance, right? And if you are standing at here, right? So if you move here, right? If you are moving here, then distances from these guys are increasing, but distances from this guy is decreasing, right? Okay. And similarly, when you're moving here, probably the distance between these guys is reduced, but these guys are increasing. So there is a midpoint in which the distances are very much optimal. And that is what this function is all about, and median function is all about. Okay. So if you are convinced with that, then AK, if it is a median, it will be minimizing this particular equation. And if it is minimizing this particular equation, we can say the AK is a median. So we just want to find out the minimum value of that. So we just going to, what we're going to do. Firstly, we will check this condition, right? Probably we can take A1 or A0, right? And find out its remainder and compare it with every other AN. Once we are able to do that, then we put everything into an array, right? And flatten this basically, right? 2, 4, it is already sorted. But if it is not sorted, we will going to sort it, and we are going to find the median, right? In case of even, right? Median are nothing but a summation average of these two guys, right? 4 and 6. But if you look at it, it will not going to matter much, right? Because the median of this guy and this guy will be 5. Okay. But if we see the cost function effectively, right? Cost function will say you have to increase. If you have a 5, then basically you have to 5 minus 1, you have to add it, right? And similarly, 6 minus 1, you have to add it. So if you take 5, or you take 4, or you take 6, I am saying it is not going to matter much, right? So we can always take 6. So what I am saying, let's say for even case, right? 4 and 6. I mean, this is also clear little bit about median also. Let's say this is A, right? This is B. Okay, let's go below, right? Yes, it is already occupied. Let's say this is A1, or let's say this is X, right? This is X tower, and this is Y tower, right? Now, and these are the only towers, or maybe there are another tower. Let's say there are another towers, right? So what I am saying, if I find out this particular point, let's say this is particular point is X plus Y by 2, right? And I say my AK, right? Because median will be calculated like that only, right? You will be finding out AK is equal to X plus Y by 2. Even if you do that, that is also fine. But if AK is X plus Y by 2, okay, then, and you want to make everything AK, isn't it? So what you will do, and let's say for simplicity, our X, original X in the question is 1, right? Just for simplicity, right? So we want to X, and we want X to be equal to AK, right? Essentially, but we want the X plus Y is the AK, right? X plus Y by 2 is the AK, and we want X to be equal to that, right? So what it will become? It will become X by 2 minus X by 2 plus Y by 2 minus X. It will become Y by 2 minus X by 2. Okay. And similarly, you want this guy, right? This guy to be also become AK, Y, right? And you notice we have not divided that because X, we have taken X, original X as 1, right? This X is different from this. So it will be nothing but Y. Okay. So this will be nothing but Y. So Y will be like Y minus X plus Y by 2. Okay. And X plus, and when you do that, then it will be nothing but minus X by 2 plus Y by 2. And if you add these two guys, because essentially we want a sum of these two values, it will be nothing but y by 2 adds up to y, and x by 2 adds up to x, right? And essentially y minus x. So if we only have a tower, and that makes sense. If you only have a tower x, or if you want and y, right? And y is greater than x. So it makes sense. You want y minus x because either you can cut that y and make it x, or you can add x minus y here, and to make it y, make it equal to x, right? Make it equal to y. So it makes sense, right? So you can either choose a median, or you can also choose these of the values, right? Because the sum, if you move here, the sum from this guy, these guys, right? All these guys will be increasing, but sum from this guy will be decreased. Similarly, when you move from here and choose this, right, as or as your optimal point in even numbers, right? Some from these guys will increase, but some from these guys will decrease. And effectively, sum will be equal only, right? Final sum will be equal because optimal point lies here. So if you go here, this guy sum will increase and this guy sum will decrease. And eventually you will be able to find out, right? Hopefully that is clear, right? Just to summarize, we got a question, and see, it is important to understand a pattern because pattern recognizing is something that is very much important. Okay, we got a question, we write in a this mathematical term, we say, ki, okay, now this is a mathematical term. One way would be, take a subtraction and should be modulus with x. But we say, ki, we know the trick, ki, we will be doing mod with x, and mod with x will be canceling out these guys. And we will be able to do it in O of n time, right? This will be O of n time. And once we are able to do it, we are able to tackle first part of a problem. It's not possible. Second part of a problem requires the finding that particular tower, and you want to make all the towers equal to that AK, right? Either by addition, either by subtraction. And you want to essentially find out AI minus AK by X, right? And did you see how we are able to why it is a sum, and we want to find out the minimum of it. Because we want to find out, and this is the optimization problem. We take x out and we want to find out this. Now, this is the inherent property of median, that if this guy will be minimized if AK is median, right? Right. If AK is median, this will be minimum, right? We saw how intuitively it looks, right? If you are moving from there, right, the distances will, if you're choosing this tower, right, degree, the distances will be this, right? But as soon as you move it, the distances from left right side will decrease, and from here you will be like they will be increasing, right, similarly. So the graph will be something looks like this, and it converges at a median, right? That is what this condition is there, right? So intuitively, this is a proof, right? You can also look at its mathematical proof, how it goes for that. And we also see if in case of even numbers, right, the median will lie in between, but we can choose any of the x or y value. Why? Because if we are moving here, the sum will be effectively increased. And if we are similarly, if we choose this, sum will be effectively increased from there. So it is a symmetrical kind of problem, right? So hopefully I'm able to do justice, but still I feel okay, there's some gap, but I guess I tried my best. So yeah, I mean, you can check out other person's video as well, but I think this much is important, like for median and object pattern recognition, right? Pattern is important, right? Finding pattern and finding its Leetcode solution, right? Again, just to quickly look at the solution, right? The first part of this is this, and second part was the finding out the median, right? The implementation is very much simple. We find out if we find the mod, right? And if mod is not equal to any of the guys, we are simply returning -1 because it was not possible, this particular condition, right? We are able to reduce it. And then this we find out the this median, and we are just doing this and find this guy and divide it by x, and that is what we are summing over, right? So this plus is summing over, and this will be going to give us our minimum options. So thank you for your time. Yeah, hopefully you should be able to understand it. So yeah, let's meet another time, right? Okay.